Good morning. So now we are going to discuss about the 29th January 23 morning session paper chemistry. Question number 31. For 1 mole of gas, the plot of PV versus P. PV versus P is shown in the figure. P versus PV. P is the pressure, V is volume. Okay. Now this graph given. So this is actually for compressibility factor graph. This is straight line indicating the Z value equal to 1. That is ideal gas. Now above that line, Z greater than 1. Below this line, Z less than 1. Now Z less than 1 means we want to select a point A, means below 1. Less than 1 is called more compressible. More compressible. More compressible is easy to convert into liquid state at low pressure. That means force of attraction is predominant. Force of attraction is predominant. Attraction predominant means A value is more greater than B. That means B is neglected. Therefore, from van der Waals equation, P plus A by V square into V minus B is equal to RT for 1 mole of gas. So B neglected. Now V into P, PV plus A by V is equal to RT. Now PV is equal to RT minus A by V. This PV value. Substitute that value in the Z formula. Z is equal to PV by RT. PV is equal to RT minus A by V by RT is equal to 1 minus A by RTV. 1 minus A by RTV. That is option 1 is the correct value of compressibility factor Z. Next one, the shortest hydrogen wavelength in Lyman series lambda. Longest wavelength in Balmer series for He plus ion. So first, what is the meaning of shortest? Shortest wavelength of hydrogen atom in Lyman series. In Lyman series. Shortest wavelength meaning is called highest energy. Highest energy. Highest energy means from the infinite distance to corresponding level. That is from infinity to 1. Infinite to 1 is called transition. That is N2, this is N1. Next one, longest wavelength of Balmer series, opposite. Longest wavelength of He plus ion in Balmer series, lowest energy. Lowest energy means adjacent level transition. Balmer series 3 to 2 is called lowest level of energy. 3 to 2. Now take the ratio for lambda values. 1 by lambda of hydrogen is equal to RZ square minus 1 by N1 square minus 1 by N2 square infinity. Same for 1 by lambda of helium. Or Z square is 2 square. 2 square minus 3 square. Then take the ratio for these two steps. That gives lambda of helium by lambda of hydrogen equal to 9 by 5. 9 by 5. Therefore, helium equal to 9 lambda by 5. Option 2. So let's take the ratio of wavelength, longest to the shortest. Shortest of Lyman series, longest of the Balmer series. Next, which of the following salt solutions would coagulate the colloidal solution formed when FeCl3 added to sodium hydroxide at fastest rate? So first, what is the reaction here? First, ferric chloride solution is added into NaOH solution. Added to NaOH solution. That will give ferric hydroxide precipitate, but will coagulate by the adsorption of common ions in the formula. What is common ion? Means ferric ion and OH minus ions from the medium. So medium is called NaOH medium. FeCl3 added to NaOH. So NaOH medium. In the NaOH medium, what is common ion present for precipitate? Means OH minus ion. That's why it is surrounded by negative charged hydroxide ions called negative Sol will be formed. Negative Sol coagulation by positive ions with a high charge, more value of charge. So what is the high value of charge? Means don't take the number of moles. That means suppose you take in as number of moles, the value becomes 10 into 0.2 means 1 millimole of aluminum ions. This is 10 into 0.1, 1 into 2 sodiums. 2 millimoles of sodium ions. This is 10 into 0.1, 1 into 3 millimoles of calcium ions. This 10 into 0.15, 1.5 millimoles of calcium ions. So don't verify like this. First we want to only effective charge ion. What are the number of moles? So that is effective ion is only plus 3 is the highest value. That is why don't compare number of moles. Effective ion is aluminum ion is effective. Suppose two options having same compound, effective calcium only, then only compare the quantity. That is, suppose it is 3 moles calcium, 1.5 moles calcium, calcium of a requirement, then you can take the 3 moles of calcium. But now in the case of this one, only aluminum is called effective ion because of high positive charge. That is involving the coagulation of this precipitate. So answer 1. Bond dissociation energy is highest for. Bond energy highest for halogens, na? That is chlorine is more than, bromine more than, fluorine more than iodine. It is a normal standard equation only, standard order only. That is bond energy order is chlorine, bromine, fluorine. Fluorine low value because of small atomic size and high interelectronic repulsion between non-bonding electrons. That is why fluorine is low value, Cl to high value. Next, Mond's process for metal refining is. Mond's process means nickel carbonyl is called Mond's process. Formation of nickel carbonyl. Because again on heating gives nickel plus liberation of CO at high temperature. That is the refining of nickel metal through carbonyl formation. Which is given compound enhance the efficiency of hydrogen storage tank. This is transportation of hydrogen in a specially made vessels, that is sodium nickel alloy or titanium hydride or magnesium hydride. This type of alloys are taken as separate vessel made up of this type of metal alloys for storage of hydrogen, liquid hydrogen. This NCERT only as per the standard equation. Sodium or titanium hydride, magnesium hydrides. Next, correct order of hydration enthalpy. Hydration enthalpy is inversely proportional to delta H hydration is inverse to size of ions. Directly proportional to charge on ions. Inverse to size, proportional charge. So charge means plus 2 is the high value. But among these two, compare the size. Size inverse. Magnesium is small ion compared to calcium. Therefore, magnesium hydration is greater than calcium. So, delta H hydration order highest for magnesium. Next to calcium. Remaining are potassium, rubidium, cesium plus 1 charge in the same group. That is K plus rubidium, cesium. Same group depend upon the size. Small cation is potassium. So potassium is more than rubidium more than cesium. Then magnesium equal to C. Calcium equal to E. Potassium A. Rubidium B. Cesium D. CE ABD. CE ABD. Option 4. Next, which behaves as diamagnetic, paramagnetic, ferromagnetic among the oxides, peroxides, superoxides. This is normally oxides are diamagnetic, colorless because of even number of electrons, O2 minus. Na2O2, peroxide. Peroxide also diamagnetic because this also even number of electrons due to even number of electrons. KO2 superoxide. Superoxide is a paramagnetic and colored. Formula O2 minus due to odd number electrons. Odd electrons because O2 6 plus 6 valence electrons, atomic numbers, anyone can use. 6 plus 6, 12 plus 1, 13 or 8 plus 8, 16 plus 1, 17 is odd number. That is called paramagnetic and colored compound. So respectively means oxide is diamagnetic, peroxodiamatic. So 2 diamatic, 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 last paramedic. Option 4. Next, A is obtained by Ostwald's method involving air, oxidation of ammonia. Upon further oxidation of air, produces B. B on hydration forms oxoacid of nitrogen along with evolution of A. The oxoacid is also produces A, gives positive brown ring test. So this nitrate test, Ostwald's process main equation, oxidation of ammonia, 4NH3 plus 5O2, oxidized to form 4NO plus 6H2O. That is oxidation of ammonia produces A. So A is nitric oxide. Nitric oxide again react with air to form nitrogen dioxide. NO is unstable. NO2 formation easily takes a reddish brown color. Reddish brown color gas. This compound B. B on hydration forms oxoacid of nitrogen. NO2 plus H2O gives HNO3 plus. So this is oxoacid. This is again compound A. Nitrate test gives brown ring test because H plus and NO3 minus. Nitrate gives brown ring test. That means A and B are NO and NO2. But NO2 in presence of excess of water gives NO2 plus H2O in excess gives HNO3 plus HNO2, nitric acid, nitrous acid. But nitrous acid unstable one. That will decompose once more to give same compound. NO plus HNO3. NO3 minus because nitric acid, H plus NO3 minus. So that is the reaction of NO2 with water. That's why NO2 is called mixed anhydride also. It gives two acids, nitric acid and nitrous acid. But nitrous acid unstable, decomposed to form NO plus HNO3. That's taken as HNO3 plus NO main compounds. That means compound of A reproducing means NO is called reproducing. So what is correct answer? NO and NO2. Next, standard electropotential of M plus 3 by plus 2 for vanadium, chromium, manganese, cobalt. Values also given here, minus 0.26, minus 0.41, 1.57, 1.97. So respectively metals are vanadium, chromium, manganese and cobalt. Values are E0, M plus 3 by M2 plus minus 0.26 plus minus 0.41 plus 1.57 plus 1.97. The textbook values only in the NCERT textbook, D and F block elements. Negative sign is called reducing agent. reducing agent. Positive sign is called oxidizing agent. That is, I will take example, chromium, E0 Cr3 plus by Cr2 plus equal to minus 0.41 volt. Negative sign is called reducing agent. Reducing agent must undergo oxidation. Oxidation from 2 to 3 plus 2 to plus 3 is called oxidation. Therefore, chromium plus 2 is called reducing agent. A substance undergoing oxidation is a reducing agent. So, vanadium is called a reducing agent that can reduce H plus ions. 2 Cr plus 2, 2 H plus is equal to H2 gas plus 2 Cr3 plus is called example of reducing action. Chromium ion is reducing agent, reduces H plus ions to form H2. So that means to liberate H2 gas from the dilute acids, it must act as a reducing agent, metal ion reducing agent, that is Cr2 plus. But Mn is not possible. Why? Means Mn value what is given? E0 Mn plus 3 by Mn2 plus 1.57. Plus value is called oxidizing agent, positive value. Oxidizing agent must undergo reduction. Plus 3 to plus 2 is called reduction. Therefore, Mn plus 3 acts as a oxidizing agent. That means this reaction not possible because it's oxidizing agent. That means this reaction possible. That is Mn plus 3 plus H2 gas undergoes oxidation to form H plus ions plus 2Mn plus 2. But not liberation of gas. It is gas undergoing oxidation to form H plus ions. That is why positive value will not liberate hydrogen. Negative will liberate hydrogen. Negative values are two metals ions, that is vanadium and chromium ions. Option 3. Correct statement about the smoke is NO2 is present in classical smoke. Both NO2, SO2 present in classical smoke. Classical smoke is reducing. Photochemical smoke is oxidizing agent. This is correct one. Option 3. Photochemical smoke has high concentration of oxidizing agent. Classical smoke reducing agents. That's reducing nature. Next, chiral complex in the following. Chiral complex means absence of plane of symmetry. Absence of plane of symmetry is called chiral complex. So, cis generally chiral. This achiral. This also achiral. Trans also achiral. That means cis or trans in the square planar complexes. This is called square planar complex. Due to square planar. Is always having plane of symmetry present. That's why square planar complexes will not show optical isomerism. Trans is having plane of symmetry. This trans also having plane of symmetry. Cis correct one because structural wise cis arrangement is platinum and ethylene diamines bidentate ligands. Cl, Cl, N, N. is having plane of symmetry called trans. But to cis molecule is no plane of symmetry. So if you take image for this one, first compound, it is same compound. That's why plane of symmetry present optically inactive in nature. But this one is different. That is called enantiomer. Enantiomers. That's why cis molecule is called optically active due to chiral complex. So answer cis molecule. Next one, correct order in the following compounds. Boiling point. Boiling point for different compounds. Different compounds molar mass increases, boiling point increases. So for A, boiling point proportional to molar mass. Molar mass increasing, boiling point also increases. So first one less than second, second less than third one. A is correct one. Density of different halo compounds, same proportional molar mass. Mass by volume, molar mass increasing, density increases. Bromide less than chloride, wrong. Bromide is more denser than chloride. So this is wrong. But chloride less than iodide correct, but here wrong. That's why D is not suitable. Boiling point of again different compounds, not isomers. Proportional to molar mass. First one less than second one because two bromines less than third one, correct one. Fourth one, same relation, proportional to molar mass. Bromine, iodine is two compound. Not correct than one bromine. This is boiling point isomers. Boiling point of isomers relation is boiling point of isomers proportional to 1 by branching. Branching increases the boiling point, decreases due to decrease of spheroidal volume or surface area. Straight chain contains more area, more spheroidal volume. That is why van der Waals force of attraction is strong in case of straight chain. That means this is normal is greater than iso, greater than tertiary is correct one. So A, C, E correct one. Option 2. pKa increasing order means first low pKa. Low pKa is called strong acid to weak acid. Strong acid means acidity of phenols. Acidity of phenols proportional to minus R and minus I effect. Because phenoxide is stabilized by minus R minus effect of phenols. Inverse proportional to reverse plus R and plus I. So all phenols only, phenol, 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 phenol. This is two nitro groups, one nitro group. That's why first one is more acidic. than second one. Second one more than fourth one, chloro. Chloro net factor is taken minus effective. That's why chloro is stronger than 2,4,5 trimethyl. Methyl is a plus R effective. That's why last place. Weakest acid is third one. So lowest pKa value for first one. Low pKa. This is high pKa. High pKa weakest acid. But question order not given, just only compound given. 1 more than, 2 more than, 4 more than 3. Next, match the following of reagents in the corresponding reactions. Hoffman degradation, also called Hoffman bromide degradation, that is bromine plus NaOH. That means third reagent using. Clemmensen reduction, zinc amalgam and HCl. Cannizzaro reaction, concentrated KOH and heating. That is number 1. Remer-Timmer reaction remaining is chloroform and NaOH. So A3, B4, C1 and D2. Option 3. Major product to P in the following sequence of reaction. Sequence is first one ketone and amide given functional groups. Zinc amalgam HCl, Clemmensen reduction. First reagent is Clemmensen. This is Clemmensen. Next followed reduction, LiAlH4, strong reduction in the acid medium. So first Clemmensen reduction gives CO into CH2. This compound given, zinc amalgam and HCl. Reduction of only ketone, not amide group. Amide not disturbed. pH 1, 2, 3, 1, 2, 3. Amide remain same. Next, LiAlH4. Lithium aluminum hydride. Reduce CO into CHOH, because the hydride gives H minus, addition on the carbon, then O into O minus. O minus takes H plus and from the medium to form pH CH2 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 O minus into OH. NH2 remain same. That is option 3. But it is one more step reduction. Again H minus H plus protonation to form OH2 plus. OH2 plus. H minus gives OH plus to form pH 1, 2, 3, 4 NH2. Because if it is aldehyde or ketone converted into alcohols, but amide again converted into CO into CH2. That means you can remove directly O as water molecule, CH2, NH2. Acid medium, OH gives again protonation with H plus to form OH2 plus. That is again elimination with H minus as water molecule. That's why CO into CH2 group, CH2 NH2 group by the LiLH4. Option 3 correct. Next, during borax bead test copper sulfate, a blue green color bead was observed in oxidizing flame due to formation of metaborates is the responsible. Metaborate formation is responsible for the color in the oxidizing flame. Metaborate compound is CuBO2 twice. This is just memory based only. Question 48. Option 1. Next, number of cyclic tripeptides formed with 2 amino acids of A and B. Cyclic tripeptides, that is RCH, COOH and NH2 is amino acid. Same type, one more. That means B. This is suppose A, assume with R1. Second one is a different structure of R, taken as R2, CH, NH2, COH. So cyclic tripeptides means only A combination, that means COOH, OH, NH2. Only B combination or 2A and 1B and 2B and 1A. 4 combinations possible. Compound will give positive Lessine test with for nitrogen and also halogen. So organic compound has to contain carbon, nitrogen and halogen. That is not fluorine. Carbon, nitrogen, here chlorine. So what is the compound having? Chlorine, nitrogen, halogen, carbon. So this is not organic compound. Carbon, nitrogen, halogen. 2. This is no carbon, not organic compound. This no carbon, not organic. Organic compound containing nitrogen and halogens. This is called methyl ammonium chloride. So option 2 correct one. Millimoles of calcium hydroxide required to produce an ml of the aqueous solution whose pH is 12 is 10 raised minus 1. Value of X is pH of 12 for calcium hydroxide. Then POH equal to 2. Then OH minus ion concentration equal to 10 raised to minus 2. 1 molar calcium hydroxide is equal to 2 molar hydroxide ions. 1 mole is 2 moles. 10 raised to minus 2 molar OH minus ions equal to X molar calcium hydroxide. So cross multiply X value equal to 10 raised to minus 2 by 2. 5 in 10 raised minus 3 molar. Millimoles formula. Millimoles equal to molarity into volume in milliliters. Molarity value 5 into 10 raised to minus 3. Milliliters are 100 ml. So 5 into 10 raised to minus 1. X in 10 raised to minus 1 is X value equal to 5. Next, molecules or ions from the following do not have odd number of electrons? Can count atomic numbers or valency, anyone is same. Valency 5 plus 12, 17 odd. 5 halogens, 5 into 7, 35 plus 1, 36, even number. 4 halogens, 4 into 7, 28, even number. ClO2, 7 plus 12, 19, odd number. NO2 plus, NO2 plus, 17 minus 1, 16, even number. NO, 5 plus 6, 11, odd number. So do not have odd number, means even number. Even numbers are 3. So 3 compounds have even numbers. Next, following reaction approaching equilibrium at 27 degrees and 1 atm pressure, A plus B is equal to C plus D, K forward, K backward given. Standard Gibbs energy change at 27 degrees centigrade is minus common taken here. So find out magnitude value. So first find out delta Z naught is equal to minus RT ln K equilibrium, because ln 10 given. So find out first ln K value for this equation. Kf by Kb. Kf 10 raised to 3, Kb 10 square, 10. So minus 8.3, 300 temperature kelvins, ln 10, minus 8.3, 300 into 2.3, minus 5.7, nearly taken as minus 6. Minus 6 kilojoules. Next, solid lead nitrate dissolved in 1 liter water. Solution found to be boiled at 100.15 Celsius. When 0.2 moles NaCl added to resulting solution, it was observed that the solution freeze at minus 0.8 degrees centigrade. Soluble product of PbCl2 formed is lead nitrate formula: PbNO3 twice to form lead ion plus 2 nitrate ions. This is complete dissolution. Which one? Lead nitrate. But how many moles we don't know. That's why let us take A moles. Complete dissociate to form A moles of lead, 2A moles of nitrates. Total number of particles are 3A moles ions per liter taken as concentration. Now freezing point value given, boiling point. Elevation of boiling point 100.15 means 0.15 is elevation. So delta Tb is equal to Kb into molality into I factor. Delta Tb is 0.15. Kb value 0.5. Mi 3A. 3A moles of particles per liter. Therefore, A is equal to 0.1 molar Next one, 0.2 moles of NaCl added to this solution. Lead react with first reaction, second reaction. Pb plus 2Cl minus combined to form PbCl2 solid or precipitate. How many lead ions? A moles present. That is given. Chloride ions are 0.2 moles. 0.2 moles. So reaction takes place for A minus X moles, 0.2 minus 2X, coefficient 2. This not required because solid state. No need to count in the I factor for solid state or precipitate. Now depression of freezing point. Delta TF is equal to 0.8. 0 minus of 0.8, 0.8. 0.8 is equal to Kf value 1.8 into concentration of particles. Concentration of particles A minus X lead ions, 0.2 minus 2X number of Cl ions. Cl also got a sodium ions, same number. That is 0.2 moles of sodium ions. This for sodium ions. Nitrate also remains same, na? Nitrate remains same. 2A moles of nitrates. 2A moles means 2 into 0.1 moles of nitrate ions per liter. Solution volume same, 1 liter only. So 1.8 Kf into concentration of all particles with respect to I factor, A minus X lead ions, 0.2 minus 2X number of chloride ions, 0.2 sodium ions and 0.2 nitrate ions by 1. This on solving X gives nearly 2.3 by 27. On solving X equal 2.3 by 27. Now finding the PbCl2 KSP. Pb concentration Cl minus whole square. Pb equal to A minus X. A value 0.1. A minus X. Cl minus 0.2 minus 2X whole square. Substitute A value and X value. Substitute A and X value gives 13 into 10 raised minus 6. X equal 2.3 by 27, A equal 0.1. That gives 13 into 10 raised minus 6. So first find out the A value, that is concentration of lead nitrate. Second, find out the concentration of the second solution on addition of NaCl, from which we can find the X value to find PbCl2 KSP value, solubility of KSP product. Pb into Cl minus whole square, lead A minus X, Cl 0.2 minus 2X whole square. That gives 13 10 minus 6. Next, water decomposes at 2300 Kelvin like this equation. Percentage of water decomposing at 2300 Kelvin, 1 bar pressure is nearest integer. Equilibrium constant for the reaction also given as 2 into 10 minus 3. That means it is the equilibrium concept of water. So H2O dissociates H2 into O2 K is equal to 2 into 10 raised minus 3. But in terms of equilibrium constant, find out the dissociation with respect to pressure. 1 0 0 1 minus alpha alpha by 2. That is for 1 bar. But we don't know pressure of water dissociated for P amount of pressure multiplied by P into 1 minus alpha P alpha by 2. Therefore, K is equal to 2 into 10 raised minus 3 is equal to H2 into O2. H2 P alpha, because here total pressure give 1 bar. So sum of all partial pressures. Sum of all partial pressures equal to 1 bar. Sum of all partial pressure means add the value P into 1 minus alpha plus P alpha by 2 is equal to 1. So P minus P alpha plus P alpha by 2. Cancel 1 P alpha. Therefore, P plus P alpha by 2 is equal to 1. But you can write here P common 1 plus alpha by 2 equal to 1. Find out alpha value, degree of dissociation. Substitute them in the Kp. Kp is equal to 2 into 10 raised minus 3. So 2 into 10 raised minus 3 is equal to pressure of H2, P alpha, into pressure of O2, P alpha by 2, 1 by 2, by pressure of water vapor, P into 1 minus alpha, P into 1 minus alpha. So your assumption alpha to be considered or alpha neglected. Alpha to be neglected because alpha is very small in case of partial dissociation and also given as constant value minus 3 means very low value. So alpha can be neglected. Alpha can be neglected. Alpha neglected means don't take 0 value, that is term not required. So 1 minus alpha 1 only. P alpha by 2 is taken as only P. Here also alpha by 2 taken as neglected, P into 1 P. That means on neglecting the P value, alpha value as negligible term, P becomes 1. Now 2 into 10 raised to minus 3 is equal to 1 alpha, because P is equal to 1, 1 alpha into 1 alpha by 2 root over into 1, because P value 1. Alpha by 2 or 1 minus alpha neglected. Then 2 into 10 raised to minus 3. Alpha into root alpha root alpha by root 2. Therefore, alpha is equal to, solving gives 2% on solving. So that means here we can take initial pressure of water vapor is P0. P0. So just put P0 or P dash. P0 equal to 1. Because sum of all partial pressures is equal to 1 bar. So we take first bar for 1 bar, 1 minus alpha, alpha by 2 in terms of pressures. Because P proportional to N in terms of number of moles, you can take as 1 minus alpha by 2. For P0 pressure, just multiply P0 value, then add all values of the partial pressures equal to 1 bar. Then P0 plus 1 into 1 plus alpha by 2. Alpha by 2 neglected because alpha is a very small value. Therefore, P into 1, P equal 1. Substitute in the formula of Kp. Kp formula H2 into half O2 whole square, root of. So, P alpha, P0 alpha, P0 value equal to 1. Therefore, 1 alpha by 2. This neglected. So, alpha is 2%. Next, wrong statements. Lambda naught M for electrolyte A is obtained by extrapolation not possible for A because it is parallel to this axis, therefore cannot intercept. So, not correct. For B versus lambda M and C, graph is straight line, intercept equal to lambda naught. Correct one. This is called intercept for B. At infinite dilution, the value of degree of dissociation approaches 0. No. Almost equal to 1. At infinite dilution becomes 1. So it's not correct. Lambda M for electrolyte for A or B can be calculated using lambda naught of individual ions. Correct one. Because sum of lambda naught of ions equal to total conductivity of the compound or electrolyte. So A and C not correct because extrapolation not possible for the compound A since weak electrolyte, and at infinite dilution becomes to complete dissociation, alpha equal to 1 not 0 because alpha equal to 1. So AC not correct statement, that means 2 answer. For chemical reaction given, it is approximation only. It is taken as straight line for concentration versus time, means taken as 0 order. But you cannot take approximation here the second region because not a straight line, variation present. This is straight line. This is taken as first order. So correct statements are overall order of reaction is 1. It is not possible to find out overall order because here not possible, second reason. Order of reaction cannot be determined in the region 1 and 3. Reaction is first and 0. That is taken as correct one. 1 and 3 nearly equal. First order straight line. This is parallel, independent of concentration. Region 2 first order not. Region 2 order of reaction is in the range 0.1 to 0.9. Cannot decide it. So correct statements are B and C because order of the overall reaction cannot be determined. Overall reaction not possible. We can take separate 1 and 3 possible but 2 not possible. That's why overall reaction not possible. So B correct one, C correct one. 2 statements one correct one. B and C. Next, sum of bridge group carbonyls in the compound. No bridge compound because it is structure wise the single metal only, no bridge. 2 metals but Bimetallic manganese is manganese bond present without carbon monoxide. 1, 2, 3, 4, 5. Same that side also 5. That's why 0. RF value find out for compound A. RF retardation factor equal to distance travelled by substance from baseline by distance travelled by solvent from baseline. Baseline means take this is baseline. That is called baseline. So substance value 3.5 from the bottom, but we want from baseline. Subtract 0.5. 3.5 minus 0.5. Solvent up to here, but a upper limit is given in terms of upper one only 0.5. So here subtract 0.5, and here .5. Total length of the glass tube is 6 cm. So total length means this entire length value 6 cm. In 6 cm, upper 0.5 minus lower 0.5 minus, that is equal to 6 minus of 0.5 plus 0.5. 3 by 5 is called retardation factor for compound. Next, 17 mg hydrocarbon takes up 8.4 ml hydrogen gas at 0 degree Celsius and 760 millimeter pressure. Ozonols of same hydrocarbon yields. This is one compound given. Acetone. Next, formaldehyde. Next, 1, 2 polyfunctional group. But number of carbon atoms, how many given? 10 carbon given. Here 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 9 carbon atoms present. One more C requirement. One more C must be aldehyde only. That is this type. That is, it is taken as 2 molecules. This is taken as 2 molecules of formal. Then it becomes 10. So we can find out formula wise or direct verification also. Formula wise means 17 mg hydrocarbon gives C10H16 takes up 84 ml. So formula wise number of moles of hydrocarbon, molar mass given na? Moles of hydrocarbon 17 into 10 raised to minus 3 by C10H16, molar mass 136. That gives on solving 1.25 10 raised to minus 4. Moles of hydrogen PV by RT, pressure 1 atm, volume 8.4 ml, 8.4 into 10 raised minus 3 liters, R value 0.0821, temperature 298. This one solving gives nearly 3.75. 3.75 10 raised minus 4. That means moles of hydrogen 3 times more than hydrocarbon. It is 3 times. That means for hydrocarbon has to contain 3 pi bonds. Each pi bond require one molecule of H2. So here one H2 requirement, here one H2 requirement, here one H2 requirement. That means the compound has to contain 3 pi bonds. 3 pi bonds or 3 double bonds. 3 double bonds. That is one way. Second method, formula verification. Formula verification, what is formula given? C10H16. C10H16 is equal to CnH2n minus 2. 10 into 20 minus 2, 18. So up to here this formula is called C10H18 alkyne, that is having 2 pi bonds. Alkyne means 2 pi bonds. But formula not satisfied na? Remove one more H2. That is called one more pi bond. Loss of one more H2, nothing but 3 pi bonds total. Up to here 2 pi bonds. Remove one more H2, become C10H16. C10H16, 3 pi bonds total. One more method is formula verification of compounds. Compounds means ozonolysis means add molecules again to eliminate O2 to find number of bonds possibility. We can take compound given. Compound given is CHO, CH2, CH2, CO, COH. Now here one formaldehyde, HH, removal of one O2, and here one acetone, can take any one, no problem. Acetone, remove one more O2, and here one more formaldehyde. Remove one more O2. Totally 3 O2 loss. That means 3 pi bonds. So 1, 2, 3, 3 pi bonds, 3, 1, 3, 1. Means 3 double bonds. 1 pi bond equal 1 double bond. 3 pi bonds, 3 double bonds. Okay. Thank you.